Section 4. You will now hear a business lecture. First, you have some time to look at questions 31 to 40. Listen carefully and answer questions 31 to 40.
Good morning, everyone. Welcome to today's lecture. Now, as part of our ongoing series on the business of sustainability, we're going to look in detail at a number of innovators who have analysed the social, environmental, and healthcare challenges of the early 21st century and developed concepts, products, and services which address the areas of greatest need. While there is an element of philanthropy about these approaches, meaning that they are business opportunities which overall have a positive value for everyone, I would like to highlight that they will still operate with the idea of the market firmly in place. These are business ideas which harness notions of the greater good, and that's part of my main thesis. Big business can and will continue to make gains if it chooses to look at more sustainable, less damaging models of production. Okay, so I've divided my talk today into two sections, each looking at a different young innovator who has decided to challenge current expectations and develop a concept that pushes both business and sustainability forwards. Okay, let's start with perhaps the most high-profile innovator out there, Dutch designer and environmentalist Dave Harkens. Now, as the issue of plastic waste has grown in prominence, so has Harkens due to his innovative approaches to reclaiming and reusing the material. You're probably all aware that each year more than 300 million tonnes of plastic waste is created, with less than 10% of this waste being recycled. The plastic which ends up in landfill sites takes decades to break down, and as it does so, it often pollutes waterways or the surrounding land with harmful chemicals. We all know that we need to recycle more of the masses of plastic waste material that each household generates. We know it, but we still don't always do it. What is perhaps needed is an incentive, some reason to do it. Harkens' solution is to encourage people to transform the plastic waste into valuable or at least usable products at home. Working with engineers, Harkens created open source plans to enable people to build home recycling centres. The precious plastics system consists of 3 simple pieces of machinery, one which shreds plastics, and the other 2 which can be used to heat and mould the recycled material into new products. To date, users of the system have created recycled lamps, containers, and utensils. A simple idea, but it's a huge change in terms of recycling, as it reduces the financial cost of collecting and sorting waste by using a domestic solution. The system allows various different types of plastic to be mixed together, and its modest design means that it can be maintained easily. Keen to unlock the commercial potential of this kind of recycling, Harkens has also made an online marketplace available for the sale of recycled goods. By following video tutorials, recyclers can learn how to make different items that they can then sell on. It's this financial incentive which is driving demand for the concept. My second innovator with an eye on environmental sustainability is materials scientist Sam Stranks, who has worked with an existing product and sought to use scientific expertise to improve it in terms of quality and usage. Strengths, and a team based at MIT, have been developing lightweight, efficient, and malleable solar conductors from a man-made, cost-effective substance known as perovskite. The material is made from two cheap and readily abundant salts, which are mixed to make an ink that can be pressed into very thin film, with all the properties of the silicon-based solar panels we currently see in the market. Less than half a cup of the ink would make enough perovskite solar panels to power an average home. Such new generation solar panels have a massive potential in terms of application. Unlike conventional solar panels, the resulting conductors will be so light that they can easily be transported into areas of the developing world which are currently energy deficient. Additionally, they can be rapidly deployed to provide aid in disaster zones, used as a cheap way to supplement existing solar farms, and provide a more cost-effective solution to the domestic renewables market. Further to this, perovskites can also be coated onto existing solar panels to ensure that their efficiency increases by up to 20%, ensuring their lifespan is longer. In terms of building greater demand, perovskite has certain features which make it attractive to investors. Given that it is lightweight and flexible, large-scale solar cells will be easier and quicker to assemble, reducing the installation costs, one of the key barriers to the uptake of renewables by many consumers. Another key feature of perovskite is that it can be made in a number of different translucent colors. What this means is that it can be used to integrate solar cells into the coatings of new and existing skyscrapers, ensuring that large-scale architectural projects could reduce their environmental footprint to become zero carbon. It's this kind of thinking which marries market forces with environmental goals to bring about a true sense of sustainability.
That is the end of section 4. You now have half a minute to check your answers.